Good afternoon, everyone. Thanks for coming in. I'm Prabath from WSO2. If you hear about WSO2 for the first time, it's a company which produces a set of open source products. Like we have an API manager, identity and access management product, stream processor, and an enterprise service bus, all released under the Apache 2 open source license. And a little bit about me. So I've been with the company for almost 11 years now, and mostly working on building the WSO2 identity server product. So it's an OpenID Connect, SAML, UMA implementation. And so I have written a few books. The latest one is Microservices for the Enterprise. So that will be out in a couple of weeks' time. And also I'm working with Manning on the Microservices Security in Action book. So that will be out early next year. Okay, so in this talk, I assume most of you are familiar with microservices, or at least heard about microservices and why microservices are different from a monolithic application, why people are moving to microservices. We've been talking about microservices for several years now, but only now, these days, we see a lot of people trying to do things in production deployments. So one reason is so microservices just as a concept is not enough. You need to have the other background infrastructure to make the microservices concepts a reality, a success. So now we have containers and Kubernetes and a lot of improvements in the DevOps, CI/CD stuff. So that all together have made microservices a success now. So that's why we see a lot of people are starting initiatives in building microservices. Any new project actually we see, they start with microservices. And please feel free to ask any questions in the middle. So why do we need to talk about microservice security? So we have talked a lot about securing web applications, securing services. So what's the difference? So what are the challenges microservices bring into security? So let's try to differentiate how we secure a monolithic application and a microservice. So then we can figure out what are the challenges we face. If you take a monolithic application, let it be a web application or a service that you deploy in your environment. So it's deployed in a single container or application server, right? So think about a web application deployed in Tomcat, right? So Tomcat is the container. Now, so all your components are in the same container. The components talk to each other in memory, right? In process calls. They are never remote calls, right? And also, you have very limited set of entry points to your application. So to a web application, it will be port 80 or port 443. You just open up HTTP and HTTPS port, that's it. No other entry points. When you have limited number of entry points, you have very limited space, or the attack surface is very low, very little. Then, since you have, once again, limited set of entry points, you can do security screening centrally, right? Everything that comes into your application can be screened centrally. If it is Tomcat, it can be a servlet filter or a Tomcat valve, any sort of interceptor based on your application container or the application you can use to screen security. Then none of the other components inside the application, they really need not to worry about security. They can assume all the requests that hit those components are validated for security. They are authenticated and authorized. There are certain cases, even at the component level, you need to do authorization, but in most of the cases, you need not to. Authorization checks and the authentication checks done centrally. And you don't need to worry about the user context. Each component needs to know who the user is. But all of these components have access to a shared session, right, in memory. So you can just access the in memory and ask who the user is and find out user's attributes. But this story becomes completely different when it goes to microservices. So in a microservices deployment, all of these components now distributed. And instead of in-process calls, now each of them talked over remote calls. Right? And now instead of 1 or 2 entry points, now we have hundreds of entry points, right? So imagine how hard it's to secure an application with few entry points. Now we are talking about hundreds of entry points. So we have a very broader attack surface. So that's one major challenge. And another challenge is how we pass user context between these microservices. For a microservice, basically the direct audience is a system. So it's not a human who is going to invoke a microservices. It's all as a system. But then again, a system can access a microservice or can invoke a microservice just by being a system itself or on behalf of an end user, right? For example, like you log into a web application, right? Then this web application wants to invoke a microservice. Then that microservice call may need to carry the user context too. So the microservice itself has to know who the end user is, right? So those are the two different flavors. Either system is doing a call just being itself, or you do a call, system does a call on behalf of another user. Right? So we need to worry about, so how do we pass this user context between microservices? The first request comes to, let's say, the foo service. So it may carry the user context. So the foo service knows who the end user is, who the system is. Now this foo service needs to talk to another microservice, right? So based on the way we scope services, to request or to cater a request, you may need to invoke multiple other services too. Then if foo service talks to bar service, there should be a way to pass this end user context from foo to bar, right? So how do we do that? And once again, we need to authenticate the service foo too, right? So those are the challenges we face. And in terms of microservice security, we talk about 4 things. One is edge security. So how to authenticate the end user and how do we pass the end user context to the microservice. The second one is service to service security. So how one system talks to another system, how one microservice talks to another microservice, and how you do secure that connection, authentication, authorization, and all stuff. Then the third one is DevOps security, like deployment security. So how do you secure a microservice in a containerized environment? The fourth one is how do you make that your developers follow the security best practices? So you need to do like static code analysis, dynamic testing, all those stuff. Because one key driving force behind microservices is speed to production. You should be able to deploy changes in a fast speed to your production deployment, right? So to do that, you need to make sure your code is secure, and you need to have all your testing built into the development lifecycle itself, right? In the CI/CD pipeline. So those things we need to worry about. In this talk, I'm mostly going to talk about application security, edge security, and the service-to-service communication. Yeah.
Can you repeat that second point that you had after edge security?
Edge security, then the deployment. Service-to-service security, deployment security, then the secure development lifecycle. Okay. So edge security. So this is the most common deployment model we see in a Microservice deployment. Right? So even if you take Netflix, it's the same deployment model. You have all the microservices, and these microservices can talk to each other, but whenever we want to expose a microservice to the outside world or to any other client, that goes on API gateway. Right? So the public interface of a microservice deployment is an API gateway. So this is a common model that we see. This is how the Netflix deployment works. So they have SUL, that's the API gateway. Then all the requests are intercepted at the SUL level. Then they are dispatched to each microservice, and microservices talk to each other. And the communication between microservices, they are not always synchronous. They can be asynchronous too. They can be HTTP, or they may use some messaging infrastructure like Kafka, RabbitMQ, like that. So you need to worry about all this stuff. Okay. So when we talk about edge security, the de facto standard is to use OAuth. I think yesterday we had a talk about OAuth. Right? So how many of you are familiar with OAuth? All of you? Great. So very brief introduction, right? I'm not going to detail. So in OAuth we have 4 components: resource owner, authorization server, resource server, OAuth client. In our case, the resource server is where you have your microservices. Right? Microservices are resources. The client can be any web application or any client who wants to access our microservices, right? So now to access that microservice on behalf of this particular user, first the OAuth client has to get a token from an authorization server which is trusted by the resource server with the user's consent and use that token to access the resources, right? So the OAuth client won't get the resource owner's credentials. What it gets is a temporary credential, a temporary token, which is only good enough for a given purpose, right? So when I say given purpose, that is defined in OAuth as scope, right? So let's say we have a service called microservice called order, right? So now I want this particular client wants to do a get to order microservice, right? Then on behalf of this particular resource owner, then the OAuth client has to request a token from the authorization server which is good enough to address that particular requirement, to do a get to order service, right? So this get order is a scope. It's another string which is understood by the authorization server, OAuth client, and the resource server, right? So the token issued from the authorization server to the client is a scoped access token which is only good enough to do a get to the order microservice, right? So if the client tries to do a post to the order microservice passing the same token, it will fail, right? So I'm doing a demo too. I'll explain that later. I'll skip this slide. If you have any questions, I can answer, but since all of you are familiar with OAuth, I don't want to go into details, right? Okay. So this is once again the overall picture. You have the authorization server, right? Then you have the web application. Users will log into the web application first using OpenID Connect, right? So OpenID Connect is a profile built on top of OAuth 2.0. And you log into the OAuth server, authorization server, and the web application will get an access token. Then web application will pass that access token with the API to the microservice, and that will hit at the API gateway level. And the API gateway will pick that access token and talk to its secret token service to validate this token. If its secret token service trusts the authorization server, it will say, okay, this is a good enough token to access this particular API, and then it will create another JWT. So this JWT is a new JWT. So we'll talk about JWT later. Any of you are not familiar with JWT? Yes? Okay. So JWT is once again another token, which is JSON token, which is signed by the issuer, right? So it includes set of claims, like it includes who the user is, what are the user's attributes, and what are the things this particular user can do. So you basically, it's a container which has set of user claims which is signed by the issuer, right? So once the first token is validated, then this particular JWT will include who the user is, who the client is, what are the user's claims, those stuff, and it is signed by this issuer and it will pass to the gateway. And then gateway will pass this token to all these microservices. Now this microservice can find out who the user is by looking at that JWT, right? Once again, all these microservices, they only need to trust its own token issuer, because the JWT they get is signed by their own trusted token exchange, not this guy, right? This guy can be even outsider. So this can be Google, this can be any other guy, right? So here you can see we differentiate the trust, right? So here all these microservices, API gateway, they trust its own API gateway and their own secret token service, and you can mediate trust between external IDPs between the token exchange and the authorization server. Any questions? Anything not clear? Right? The reason is, like, you can bring in any other IDP here, any other authorization server without changing any of these. Because all these just trust its own token exchange. Right? These guys even can be outside your domain. Right? Okay. So that's the edge security part. So edge security terminates here. Then this JWT is the one which propagates the user identity and the client information, everything to the microservices. Okay. Then how do you, this title is actually not correct, right? How do you secure service-to-service communication, right? So there are two main ways. One is to use TLS mutual authentication between services and use JWT itself, or else we can use a combination of both, right? So let's talk about certificates. So what are challenges, right? So if you take a microservice deployment, we are talking about a deployment with hundreds of nodes, right? And these nodes will once again won't stay forever, right? So, but once again, like this is what we want to be, but it's not where most of us are today, right? So most of us are today, even who are doing microservice deployment, they are not even using Docker or any containers. They just deploy their microservice on just as Spring Boot or any other application container. But this is where we need to go into large-scale deployments. They use containers and Kubernetes stuff, right? So when you talk about large-scale deployments, a lot of microservices, then each microservice should have its own key pair, right? To participate in an MTLS handshake, right? Now, so what are the challenges? How do we make sure that these keys are not, when these keys are revoked, how do you take that into consideration when validating a key, right? The revocation is something really hard to track, right? There are multiple ways like CRLs, OCSP, those stuff, but once again, it's not very reliable. So what if the OCSP endpoint is down? What should we do, right? We can cache that decision, but once again, when we cache, we make security decisions based on stale data. That's not good. So that's why now people try to forget about this token revocation, certificate revocation, and they just rely on the expiration time of certificates. So this is where we talk about short-lived certificates. In Netflix deployment, they have TLS mutual authentication between all the microservices in the internal deployment. They don't worry about token revocation. They only worry about expiration. And expiration of certificate is like about 4 minutes, right? Once again, the reality is, so these are very nice security concepts, right? You need to have the right infrastructure to do that, right? So they have a CA, right? So what the way they do that is, so whenever you spin up a node, right, you embed a long-lived key to that particular node. And that node will use that long-lived key to talk to a CA and generate a key pair, right? And they rotate that keys every 4 minutes. So there are things that helps you doing this stuff. So we'll talk about those things as well. So trust bootstrap, certificate revocation, key rotation, those are challenges we see when we secure microservice deployment with MTLS. But this is the most common thing we see, but people don't worry about token revocation. Okay, so this is something that helps you manage these certificates or bootstrap trust between nodes in your microservice deployment. Anyone heard of SPIFFE? Okay, SPIFFE is a specification and Spire is the reference implementation of that, right? So if you are familiar with Istio, any of you heard of Istio? Kubernetes? Yes, right. So Istio is a service mesh running on Kubernetes. So I'll talk about Istio 2 later. Right, Istio is once again using a SPIFFE concept to some extent, right? So let me explain how SPIFFE works and how it bootstrap trust, right? So to your left-hand side, the workload is a microservice, right? So let's think about that you are going to deploy this microservice in EC2, right? So you have EC2 node and you are going to deploy your microservice in the EC2 node. Then along with the microservice, you also need to run this Spire node agent, right? In the same EC2 node, you have your microservice, then the Spire node agent, right? You spin up the EC2 microservice, and then when the Spire agent gets started, it will talk to a Spire server. There's a Spire server you need to run in your deployment, so it will talk to the Spire server, number one, right? So when you talk to the Spire server, how does the Spire server authenticate the Spire node agent? It is done with some platform-specific stuff. Like if it is AWS, you pass the AWS metadata document, right? So AWS metadata document has all the metadata related to your EC2 instance. And you can only access the metadata API within an EC2 instance, and what you get is the information related to that particular EC2 instance. And that API is not protected. I mean, you can only access it from an EC2 node, and what you get information related to your EC2 node itself. And it is signed by AWS. Right? So now Spire agent will get that AWS document, and you will pass that to the Spire server. Then Spire server will validate the AWS document, see whether it's signed by AWS, then it accepts that, then it finds out node information, EC2 instance and the security groups, those stuff, right? Then it has a registry which defines what are the microservices that can be run on that particular EC2 node, right? So now we know the EC2 node, then the identity registry defines what microservices are eligible to run on that particular EC2 node, right? And each microservice has an identifier, right? So that is called SPIFFE ID. You can see on the top, right? And then each SPIFFE ID has some condition, like under which condition I should assign this SPIFFE ID to that particular microservice. Is it running on this AWS security group? Is it running on this particular UID? Is it running on this particular process ID? Then I am going to assign this SPIFFE ID to this particular workload, microservice, right? So those conditions are called selectors, right? So SPIFFE ID is given to a workload only if it satisfies set of conditions, right? These conditions are called selectors. Now what the node server does is, it will pass all the SPIFFE IDs which are eligible to run on that particular EC2 node along with the selectors, right? Then those will be sent to the Spire agent. Then when the workload, the microservice itself spins up, and when it wants to talk to another microservice, first it has to find out who am I. It has to get its own identity, right? Then the microservice will talk to the Spire node agent. So this is an in-process call, right? So if it's in Unix, it's to the sockets, right? To call the Spire node agent and ask who am I. Then the Spire node agent has a set of SPIFFE IDs and set of selectors, right? Then it will run through all the selectors and see whether there's a SPIFFE ID which matches this particular workload. It will check the user ID, it will check the process ID, other stuff. And if it finds a selector corresponding to the workload, then it will assign that SPIFFE ID to a particular node, right? To assign the SPIFFE ID to that particular node, first this Spire agent will create a certificate key pair and generate a CSR and embed that particular SPIFFE ID into the certificate itself and send the CSR to the SPIFFE server. Then SPIFFE server will sign that certificate, right, and send the signed certificate back to the node agent along with other certificates belong to other microservices that it can trust, right? Then the Spire node agent will pass the signed certificate and the private key and the public key to the microservice. Then microservice can use that to talk to another microservice, right? So this solves the trust bootstrap problem in a platform agnostic manner. And if you run this in a Kubernetes environment, right, then the node agent will authenticate to the node server with some information related to the Kubernetes environment. Right? Any questions? Okay, so even Netflix is using this one. Yeah. So once you have the key pair at the microservice, you can use it for anything, right? So now if this microservice wants to do cross-domain communication with set of services security with OAuth, what you can simply do is, you can authenticate to an OAuth security token service, passing with MTLS, and then get a token, and use that token to access other APIs, right? So once you establish key pair, you can use it to any purpose. You can generate your own JWT even, right? So JWT is signed token. You can sign the JWT with your own private key. And once again, this SPIFFE agent, Spire node agent takes care of rotating the certificates. By default, the lifetime of certificate is one hour, right? And it makes sure that keys are rotated every 1 hour. So all the key rotations now handled by this BIFI itself. Okay, so JWT we talked about, like very abstract level. It's a container which carries your claims. So these claims can be your attributes, who you are, and what you can do. And these are signed by the issuer. Right? So in reality, so we all talk about JWT, but in reality JWT doesn't exist. Right? So what exists is a JWS or a JWE. JWS is JSON Web Signature. JWE is JSON Web Encryption. The 100% definition of 100% accurate definition of JWT is compact serialized JWS or a compact serialized JWE. Right? So JWS or JWE can be serialized into multiple formats. It can be JSON serialized or it can compact serialized, right? So this is a compact serialized JWT, right? So this is in fact a JWS. So this is a compact serialized JWS, which is a JWT, right? If it is encrypted, then compact serialized JWE, once again we call a JWT. In OpenID Connect, we use JWT, right? So this is called the Husey header, right? Which includes a signing algorithm, those stuff. Then this is the body, right? And this is the signature. In a JWS, right? A JWT actually is a JWS or a JWE. In a JWS, you have 3 parts. So the third part is the signature. Right, so I'll skip some of stuff. So I'll do a demo now. I'll show you how to secure a microservice with JWT and get a token with OAuth by talking to security token service, a JWT token, and pass it to a microservice. And here we use Ballerina. Anyone heard of Ballerina? Not that Ballerina programming language, right? So Ballerina is a programming language, so mostly developed by WSO2, and we have a lot of committers coming outside too. So this is a compiled, type safe, and mostly like concurrent programming language, mostly targeting the development of cloud native applications. So you can use this to develop microservices or to integrate microservices. Right? So this is becoming quite popular now. So I'll show you how to run a microservice in Ballerina, deploy it, and then invoke it with a JWT, and then again deploy this in a Docker container and invoke it as well with a curl command. So this is my microservice written in Ballerina. So okay, right. So now, if you go here, actually you can learn more about Ballerina. If you go to ballerina.io, you can learn more about it, and so this has plenty of examples. Right, so this is my Ballerina service. Here you can see this is secured with JWT. I am using scheme as JWT. Right, to access this microservice, you need to pass a JWT, and the issuer of the JWT should be any issuer. Here I am using WSO2IS, so this is the identity server itself. It can be any product which issues a JWT access token, right? And then audience, so when you issue a JWT from a token issuer, it has to be for a particular audience. And the receiver should check whether the audience of this particular JWT is known to me, right? That's it. So, so you can see this is just a echo service. And then again, to access this microservice, you should have the hello scope, right? You should have the hello scope, like. So whenever you request a token from the token issuer, you need to request it for the hello scope, right? Right, so now, so I have the STS running. So this is my security token service. I have done all the configurations. And if you look at here, this is my environment SSH. So this has all the endpoints. This is the endpoint the curl client will talk to get a token, right? And you need to have both client ID and client secret. So now if I just run jwt.sh, so I will get an access token. So this is an access token jwt, right? So this is in fact the command I use here. Just using client credentials, OAuth, it's an OAuth flow to talk to the OAuth endpoint and get a JWT, passing my client ID and client secret. Right. So now I have my JWT, and this is compact serialized JWS. If you want to see what is in it, so there's a nice plugin. If you go to JWT IO, you can get it. Right? You paste it. You can find all the information here. So here you can see the audience is this one. This is what is expected from my microservice. And the issuer is WSO2IS, and this carries a hello scope. So this is a good token to access my microservice, right? So let me start microservice now. Okay, so this will spin up the Ballerina microservice. It started and it's running on port 9090. Now to invoke this microservice, I have another script. I need to copy this token and export as token. And now this is the curl script I am going to run. Right, you can see I am passing this OAuth header, the token that I just exported to my environment, and call this microservice. Right? Say hello microservice, right? Okay, now if I run this one, okay, so now I get hello world. Right? So now let's try to invoke this service with invalid scope, right? So if you want to change the scope, I just need to change this jwt.sh. So here it's asking for a token with hello scope. I'll ask for hello too. Now if I run jwt, I get another jwt now. And if you look at this one, this has hello 2 as a scope. So authorization should fail, right? Export the new token, invoke the service again. Still, maybe I did the wrong stuff. Okay, this is the token hello 2, right? Then I need to export this token, right? Still, for some reason, okay. Why? I didn't reboot the service. Okay. Okay. Authorization failure, right? So this token is not good enough to access this particular service. So now I'll show you like how to create a container and deploy this microservice that I just created. So with here you can do it in the code itself. You don't need to create Docker files by yourself. So this programmatically with an annotation you can define it. So here you can see I need to import this package and then Docker expose and define the Docker config. Right. Then I can deploy this. See. Okay. Now if I want to build this one, I just run the build script. So this will create a Docker image out of my service, right? So it's created. And now to run this Docker container, so I'll use Docker run. So this will spin up my microservice that I just deployed in a Docker container. So it's listening on this port 9090. So now if I call this one, right, still failed because it's the same microservice that I deployed, right? This token is not good enough to access that microservice, and yeah, so that's how it works. Any questions? Right. This is just a client to service invocation with the JWT, right?
So the removal that you just did, that would be done automatically, right?
Sorry?
You remove, so when you had the failure, right, so you put it below 2,
Yeah.
it kept saying it was good, right?
Yeah. We don't reboot the service because I did the code change at the service level. I didn't reboot the service. Yeah, I basically changed the service code. Right. Any other questions? Okay, so let's go back to the slides. Okay, so then let's have a look at a set of service interaction patterns, right? So this is the most common one, like you trust the network, but this is not the recommended one when we talk about like zero trust network. So here from the gateway, so gateway is the API gateway, it terminates the end user connection, and it will creates its own JWT, and it will pass to the microservice, and each microservice will have its own proxy, right? So this is basically service mesh architecture, right? So under service mesh architecture, we have a control plane and a data plane. In each data plane, each microservice has its own proxy, right? So Istio is a service mesh, and Istio in the data plane, you have the Envoy proxy, which is developed by Lyft, right? And in the control plane, you can define policies and push those to all these proxies. So all the policies will be enforced for each microservice at the proxy level. All the inbound and outbound connections from this microservice will go to the proxy, right? So in this particular pattern, proxy won't validate anything, it simply pass through it, and then just pass the user context and HTTP header, use TLS, and you just trust the network, right? So this is not a good pattern, but this is what we see today, right? Then the other pattern is, right, so the cell gateway, it terminates the connection, it creates its own JWT, which is signed by its trusted STS, and you pass that STS to this microservice through the proxy, then the proxy will validate it, right? So when you develop microservices today, you really need not to worry about generating JWTs and validating JWTs. So these proxies are there to do that, right? So this proxy basically will take that burden and do it for you. Now you pass a JWT, the proxy will validate it, proxy will make sure that JWT is signed by this STS and pass it through here. Then once again, when this microservice goes to another microservice, in this pattern, you pass the same JWT. So whatever JWT you got from the gateway, you pass the same JWT across other microservices, and you use MTLS for the service authentication. So user context is passed to the JWT, service authentication happens with MTLS. So nested JWT, here you don't use MTLS, right? You use another JWT. So this nested JWT, the outer one is signed by the microservice itself, and it embeds the JWT sent from the gateway, right? So the internal JWT carries the user context, outer JWT carries the service context, right? So you pass it between microservices. So you don't need to use MTLS there. So once again, SPIFFE is important. For all these patterns, each microservice should have its own key pair, right? So this is the most secured pattern, right? So in this case, you get the JWT, which is originally signed by this particular STS, and this proxy will validate that. And when this proxy wants to talk to another proxy, this particular service wants to talk to another service, it will again talk to this particular STS, pass the original JWT and get a new JWT, and use that JWT to access a particular proxy. The reason to do that is, In this model, each proxy will have its own audience value. Remember the audience we saw in the microservice? Earlier, if you share the same microservice, then audience value in all the microservices should be same, right? Otherwise, they will reject it. In this model, each microservice can have its own audience, right? So then you can even enforce any author access control checks here when you issue a JWT for this calling microservice. See whether this microservice actually can access this microservice. If not, it won't issue a JWT for this particular audience to this particular microservice, right? But in practice, we see people use the same audience across all the microservices in a given deployment.
Going back to one slide.
Yeah.
So is the STS like the repository for where the audience is up? And it just gets in, because you're saying it goes from service, right? It goes to STS, grab that information that allows it to go through the proxy and then talk to the next proxy.
STS is a token issuer. It generates JWT. Right? In my example, remember I did the curl to the STS and get a JWT. Right. So in a similar way, you need to call this particular STS endpoint, get a JWT, and while building the JWT, STS can evaluate set of access control policies and see whether actually this microservice can access this microservice. If not, it won't issue it. Right? So there can be policies enforced at the STS too.
I guess you're asking where the audience actually come from. I'm curious to where the audience is actually generated and who all is.
Yeah, so that's this identity register that you saw in the SPIFFE deployment. There should be a governance model, governance policy that you need to define.
Okay.
And the STS is aware of that policy. So based on that policy, it defines who can access what. Right. So cross-domain scenarios, actually it's the same model like this, but it goes between multiple domains. So whenever you want to talk to a microservice from another domain, then first you need to generate a JWT which is trusted by this particular domain. Right? So then you need to have a trust relationship between these two secret token services. Okay, so finally, so that's the authentication part, and we covered to some extent the authorization as well. But to enforce access control logic at each microservice level, there are two approaches. So one is to have a centralized policy decision point. Right? You have central PDP, and each microservice, when it wants to authorize a request, it will talk to this particular PDP. Right? But in this model, like you need to have once again central PDP. This is not a very good model. So the other model is embedded PDP. Each microservice will have its own policy decision point, and policies are defined centrally and pushed to all these microservices. So whenever there's a new policy, it will send an event to some messaging infrastructure, and all the interested microservices will get notified. Then you can pull the policy. Right? So actually, you don't need to worry about most of this stuff if you use Istio service mesh. So Istio in its architecture itself builds these patterns. So then this does the policy distribution. Then how do we define policies, right? So this is once again one of the upcoming policy language for microservices called OPA, Open Policy Agent. So it has its own language. I don't think I have an example. Own language which defines who can access what. So this is once again getting popular. Netflix, for example, they are using OPA internally. Yeah, any questions? Okay then, thank you very much.